Okay, hello guys. So today I will show you how to rank the GCM, multiple GCM, by using KGE, Kling-Gupta efficiency. So let me share the screen. We are using R for this calculation, right? So I will show you some of my paper that use this. You can find my paper. Okay. I think for my paper heat wave. Okay, heat wave. Okay, this paper. You see in this paper, if you look at the method section, I put the procedure here. So for future projection, the skill of the GCM to replicate the historical Tmax was ranked by using Kling-Gupta efficiency by using KGE. So we rank the historical GCM. We want to identify which GCM is the best. Actually, so that we can get the subset of the base GCM. But for this case, for this tutorial, I will rank the GCM by using KGE and then visualize it by using Heatmap. We still not ranking it, aggregate the rank by using CPI yet, but because there is usually in the study area, if we use gridded data, there is a lot of grid. Somehow we cannot visualize one grid by one grid, right? But the best way to visualize this up to this point is by using heat map. So for example, I think let's see, uh, we rank the GCM. I didn't sure how we rank the GCM here, but actually we performance selection and ranking of the GCM. We just put the table, which one GCM is the best, which class, after we do CPI. But for this tutorial, I will show you how we calculate the KGE and then calculate all the KGE for each of the GCM. And then we just want to explore first, visualize and explore and see how exactly it looks like. Okay, for these purposes, I have prepared the R code here. Okay, like this cover everything. So we use KGE is a statistical metric. So we use only KGE because that is a composite. We call it composite matrix. It cover a lot of things. It's cover correlation. It's cover ranking or bias or something like that. That's why a lot of paper that out of many statistical performance metrics out there, they use KGE. So yeah, this is the one of the simple way I think to calculate to rank the GCM by using KGE. So Kling-Gupta efficiency. So for these purposes, we calculate first the KGE by using library matrix, library hydrograph. So we run this code, and then we set our working directory where we put our GCM, and where we put our chips data. So first, I show you the chips rainfall data that we have. So this is working directory. So our working directory is here, working directory, and this is our chips gridded data. Okay, this is our chips gridded data, right? We have here month and day from 1981 to 2014. And I have grid V1 until 178. This is our grid historical data, chips rainfall data. This is how we arrange the data for historical, because when we calculate the KGE, we want to compare the performance of the GCM with the observed one, right? The observed is chips. So the GCM we compare with the chips, and we have about 24 GCM, for example, compare all of that GCM with chips data and calculate the KGE. And we want to find out which model is the best in terms of matrix KGE. So prepare your input data, historical data like this. And then for all of your GCM, you see all of my GCM I prepare in the same folder. For example, I I open one of the input data. So this is the access CM2 GCM. We have here month and day, and also 178 grid point. We have 178 grid point. I show you another GCM. CM. I think this is the same GCM. Why I put 2 here? Let's see. 12419. 12419. So this is actually the same GCM. We can remove this one. Yeah, we can remove CM2. CM2 here. This one is CM2. Okay. For example, analysis, I open scan ESM2. Just follow the same thing. Year, month, and day, and then you have 178 grid point up here. The heading doesn't matter, but make sure you have year, month, and day, and this can be V1 until V178 or whatever. But because we will just read the column, we will not read the column headings later on in the code. So prepare all of your 20. For example, here I have 23 GCM. So prepare everything properly. Please make sure that it is tally. This is 1981. You see, make sure that all the date is there for each GCM. So you see, it's all there because last time I show you there is a missing GCM, right? There is missing value in the GCM. Make sure you fill all of that missing value first. After that, you can do this assessment. Otherwise, always some problem. So don't do that. Don't trouble yourself. Fill the missing value first. Make sure all the missing value in the GCM is filled. After that, you can do this KGE. Okay, now we have 23 GCM and we want to compare this 23 GCM with chips rainfall data based on KGE matrix. So put all of your dataset name here, list of the GCM here. My dataset here is I put PM underscore access CM2, but I just read the access CM2. Later on down here, I will read only PM underscore to adjust the, so it will read all PM, something like that. So list all of your GCM here. Okay, I read list of all the GCM, and then we make the loop for chip because we want to calculate the KGE, right? The KGE is calculated here, GOF. GOF here, it will get the calculate the statistical matrix. So what statistical matrix it will calculate? It will calculate all statistical matrix actually. Later we will only extract the KGE. So this one will calculate all the statistical matrix. So it's up to you later on if you want which metric you want to use for calculating to assess the GCM. So in this case we will calculate all of the statistical matrix. So we compare GCM with the observed one. All of this GCM we will compare. So here we have chips rainfall data. Put your input chips rainfall data here. So my name of the input data for chips is here. I put it here, and then make sure you make the right column for the grid that you want to compare. So for example here we have this GCM. We want to compare the grid start from grid number 4. 1, 2, 3, 4. 4 until 181. 181. You can see down here 181. So I put here 4 until 181. And here also observe you read 100 to 181. GCM also you need to read from 4 until 141 also. So for the GCM, I read only PM and all of this gridded data, all of this GCM. PM, this data PM, this data PM, this data PM, this data. Make sure you rename everything is properly here. And then we calculate the matrix by using GOF function, observe, compare with GCM, and then we validate we get the validation of Peninsula Malaysia, and then it will give you the result for each of that GCM. So for example, here you see I have get all of this result for each of this GCM. So for example, I will put it 2 here so that we can have a different output. So I run here. You see it calculate all of the metrics for compare GCM with chips dataset. It's better to calculate all the metrics because the GOF function, they keep updating that one. So the number of the matrix keep increasing so that later on we can adjust back the which metric we want to collect, because the column will be different because they keep updating this function. You see it's already calculating three of this. We can open this result, and you can see for each grid point 178, right? So in the left here we can see all the metrics that it calculates. So there we have here 28 metrics. You see 28 metrics. It keep increasing. Last year it's about only 21 metrics, and then they keep increasing. There is the new one, KGE NP, KGE KM, IF, something like that. So these metrics keep increasing. So we can see the KGE is in column 25 here. So we need to capture that column later on so that we want to get that column only to visualize by using Heatmap. So you will get all of this result. I don't need to run all of it, but we already have this output actually. I don't need to run it. I will delete this. And the output, the same output is here. You can see the same output is here. We have just now we have 28, right? This one is 26. So you need to capture the right output here. The right output. Now it's 23 here. So the latest one, they seem to have more statistical metrics that they use. So they have a lot of statistical metrics here. They have ME, MAE, MSE, RMSE, P-bias, and RMSE. Some paper, they use many metrics, but in this case, we only use KGE because this is a composite matrix. So now we continue with the code here. Now we have all the result, right? Now we want to only capture the KGE. KGE. So I want to capture only KGE. So we set our working directory, and then we read the GCM list. Make sure you have this GCM list. We read our set working directory is the same folder. We prepare our GCM list file. This is the GCM list file where we prepare our GCM from in alphabetical order from number 1 until 23. For in this case, my study, I have 23 GCM, right? So we prepare easily. Everything you need to prepare alphabetical order so you will not get confused. So prepare something like this, another input file, number 1 until 23, and the GCMs, all the name of the GCM that you use. So you read that GCM list, and then because we want to capture list of the file name that we want to collect here, also we run this one. So all the validation output that we have just now, you must put it there here. There is about 23 here. 1 and 2, 3, 4, 5 until 23. Make sure all the comma is there. Make sure everything is case sensitive. Make sure list all the file name, and then we combine the statistic. They combine the state function that to combine the statistic, state combine, and then we want to define which statistic that we want to collect. So make sure you collect the right statistic. If you doesn't collect the right statistic, just do the change here, maybe 25. Just now it's 25, right? But in this case, because my based on the output that you have, you see here I have from here, from ME here, ME here, you calculate from ME here, not from up here. From ME here until here. So you see count here 22. So KGE, don't look at the count number 23 here. From here until here is KGE is 22. You see 22. So KGE will be 22, KGE LF will be 23, KGE NP will be 24. But if you want to collect for data for IMSE will be number 4. P bias will be number 7. You can change here. So run this one. Now we loop the statistic, combine all of this statistic, and then get the output data. So we will get the state for table for composite matrix. So for example, we state for composite matrix and underscore here because I collect 3 statistic, it will give you 3 data set. So I have this 3 data set will be output for this code. So for example, I just want KGE. This is the KGE value for KGE for each GCM. We have 23 GCM for each GCM and for each grid point. So very, very comprehensive of statistical assessment. Now for this one, you change the heading here. I changed here just now to GCMs so that easy for another code to visualize this result. Make sure you change here GCMs. Now we want to prepare a heat map of the ranking. So for this one, you use ggplot2, rshape2, and pheatmap. If you don't have this library, just install it first. And then one. And then you read the same working directory. Now I want to, if we put this table into the paper, it's impossible, right? We need to somehow we need to visualize this one by using, the best thing that I can think of is by using heatmap. So you can load that data set just now for the KGE, output of the KGE. Load that data set, extract the GCM model data here, and then row name, GCM name, and then we define column name assuming the data from V to Vn. So it's better for you to put the heading here from V to V1 until V178. So it's very easy to do. You can just put V1 here and then just drag everything and it will be until Vn. So do that one first. So I'll calculate V until Vn. And then we generate the heat map. So just follow this code. We use cluster row. By using pheatmap, we can have the cluster also, but it becomes very messy. So I put it as false here because we don't want to make any cluster. We just want to look at the heat map of the. Just follow this generate to heat map. This code you can see here, right? So I put it quite bigger here so everybody can see. So I put the color. You can play around with the color here. I'm not very good, I think, in terms of color. Just maybe you can, but I think red, white, and blue is okay. But in your case, if you want to change the color, it's up to you. So we run this code, and then we can get this heat map. You see, and the right here is the list of the GCM from alphabetical order, and down here is the grid point. So I make interval of 10 here because if maybe I can put 5. I can put 5 here. You can change interval here, 5 to 5. If you put to 5, okay, it's okay. If you doesn't put interval, and it become very messy down here. So I put V1 until V176. Now it looks a little bit tidier. Now we can see the legend here, 2 until -2. So the best KG is blue here, 1. If higher than 1 is overestimate, lower than 1 will be underestimate. So you see some grid point they can capture very well the GCM, I think, but some area of the study area the KG is very bad. So here we can roughly see like Easy Earth is good in some area. Maybe No SME is good, also good. Access CM2 also good, but some place is not very bad. Where is very bad. So we can get the result from. We can visualize the ranking of the KGE by this way. You can just copy this one, put in your paper. That's all. I think that's all for ranking of the KG. Later on, I will show you how to aggregate this ranking just to get one value so that we can rank which GCM is the best. But right now, we rank the GCM based on KGE, and the ranking right now is for each grid point. For each grid point. And somehow we need to aggregate everything, right? We need to decide which GCM is the best. If we look like this, we don't know which one is the best. A lot of data, but somehow we can see how it's going on. So it's a process. We can look the process, something like that. Okay, I think that's all for today. Thank you.